Okay, guys, so the third way we're going to solve systems is through a process we call elimination. It's called elimination because you want to eliminate one of the variables. And so what that means is manipulating one of the problems to match the other one in some form to get rid of one of the variables. So notice that this is an 8 and this is a negative 16. So this is a multiple of 2 away from 16. Well, I'm sorry, negative 2 technically, but we want a positive 16 to add to a negative 16 to give us 0. And so if I multiply everything in this top row by 2, I have 16x minus 12y is equal to negative 40. Okay, now I have two equations now, negative 16x plus 7y. And this one represents the other equation. Multiplying by 2 does not change anything as long as I do it to everything. Now, this 16 and 16, that's 0. Negative 12 and 7 is negative 5y. And negative 40 and positive 30 is negative 10. Divided by negative 5. Y is equal to 2. Okay, so that's the first one. And then we just go back and do what we did in the other problems for substitution. So we've got y is 2, so we can plug it into either equation, this one or that one, or we can even use the original one. So let's use the original. 8x minus 6 times 2 is equal to negative 20. Okay, I'm going to make that nicer. Okay, so this is 8x minus 12 is equal to negative 20. Add 12. 8x is equal to negative 8. Divided by 8. X is equal to negative 1. So we have negative 1, 2 as our solution. And always put it in an ordered pair just to remind yourself that it is a point that is being intersected. We're going to do one more example of this, and then I'm going to talk about independent and dependent systems. So next one, we've got negative 24 minus 8x is equal to 12y. And we've got 1 plus 5/9 y is equal to negative 7/18 x. Well, this one doesn't look very cute. So let's get the x's and y's on one side. You don't necessarily have to. You just need to make it match. But I'm going to get the x's and y's on one side. So to do that, I'm going to add 8x to the other side on this one. And I'm going to subtract 5/9 on both sides on that one. So that's going to give me negative 20. I'm going to write this in another form. This is going to be 8x plus 12y is equal to negative 24. And for the other one, it's going to be negative 7 over 18x. Negative 5 over 9y is equal to 1. Now, I don't like these fractions, and it makes it hard to figure out what the number that goes into them are. So we can use a trick that we used up here, right? We multiplied everything by 2 earlier. What's the LCD of this? The LCD of the bottom is 18. Because 9 goes into 18, 18 goes into 18, and 1 goes into 18. So, we're going to multiply everything on the bottom by 18, and watch what happens. Okay, so, we've still got our 8x plus 12y is equal to negative 24. 18 and 18, well, 18 divided by 18 is gone. That's 1 minus 7x. Okay, there's a minus here. So we've got 18 divided by 9 times 5y on top. So this is going to be 2. This is negative 10y is equal to 18 times 1, 18. Okay, now this one's not as nice as the other one. Notice that in the other case, everything was a multiple of, or I'm sorry, 8 and 16. 8 goes directly into 16. This one does not have anything that goes like that. We can multiply by 7 up here and 8 down here. Or we can get rid of y. So let's do the 8 and 7 trick. So I'm going to multiply the top by 7, the bottom by 8. I do not need to switch any signs because one's positive and one's negative. So this is going to be 56x plus 12 times 7 is, I think, 84. 84y is equal to, 12 times 24. That's a big number. I want to use a calculator just so I don't do anything wrong. Give me one moment. I just don't want to make a mistake in this video. So we have 12 times 24, that's 288, negative. And then on the bottom we have negative 56x, which is what we wanted, minus 80y, and 18 times 8 is 144. Okay, so we've got that. We're going to add the two together. This is 0. This is 4y is equal to negative 144. 144. I think that's 36, but I could be wrong. 4 times 36, 144. Yeah, so this is 4. Y is equal to negative 36. Okay, so we've got y, negative 36. So we've got 8x plus 12 times negative 36 is equal to negative 24. So this is 8x minus 36 times 12 is 432. Negative 24. Add 432. Minus 24. It's 408. So this is 8x is equal to 408. And I believe, if I'm not mistaken, this is x is equal to 51. 51 negative 36. Let me make sure. I think that's right. 408 divided by 8 is 51. Yeah, we're good to go. And so that is taken care of. Now, there are other instances that happen, guys. We could have, one thing to point out about this, imagine graphing this. If you had to graph and you had to find it intersected at 51 negative 36, you'd need a pretty big piece of graph paper if you were looking from the center to graph this. So keep that in mind. So that's why we have methods like elimination and substitution to help us. For instance, let's look at another problem though. We have 2x plus y is equal to 7. And let's say, for instance, you have 4x plus 2y is equal to 14. Okay, we have two different equations. And let's say we want to solve them, and we're going to use elimination. Well, we can multiply this by negative 2 to get negative 4 to cancel it with the 4x. So let's multiply by negative 2. This is negative 4x minus 2y is equal to negative 14. Well, we subtract, that's 0. Oh, that's 0. Is equal to, oh, this is 0. So what does this say? This says 0 is equal to 0. Well, that's true. So what does that mean? That means that these lines are the same line. Therefore, there are infinitely many solutions. Now, conveniently, the problems we've been doing have had integer solutions and not fractions, but it is possible to have fraction solutions, guys. So keep in mind that you might have a fractional place where these two things intersect in some of your examples on the homework and things like that. So keep that in mind. Let's look at one more example. If I do x plus y is equal to 3, and I do 2x plus 2y is equal to 9, and we try elimination on this, let's multiply this one by negative 2. Minus 2y is equal to negative 6. 0, 0, 3. 0 is equal to 3. Well, does that ever happen? No, false. These lines are parallel. There is no solution. Which should make sense, right? Because we know parallel lines do not intersect. What solving systems does is it shows you where intersections happen. And so if they're parallel, they won't intersect, so they won't have a solution. I hope that that's helpful, guys. Make sure you're trying your best. Try this student practice when you get a chance. Do the homework. I'm going to ask for very specific ones on the homework this time, so make sure that you're doing all of it. Thank you guys for watching.